Okay, so today, start the new unit. Last unit. This is it. It'll be a short one. We talk about the square root property first of all. So, what is the square root property? We talked maybe a tiny bit about this, about a month ago, but not much. So, here's the square root property. It just says that if a is some real number and x squared is equal to a, then we can solve for x by square rooting both sides of the equation. But you have to include, this is the part that's a little mysterious, you have to include the plus or minus in your answer. Okay, and the reason for that, I'll show you the proof. If x squared equals a, does everybody agree that to isolate that x, I would just square root both sides, right? So the square root of x squared equals the square root of a. Okay, but the square root of x squared, what is that? What's the square root of x squared? Okay, it seems like it ought to be x, but it's not. It's the absolute value of x because it always gives you a positive output. Like if I let x be some negative number, like -3 squared is 9, and the square root of 9 is +3, right? So if I input a negative, it automatically gives me an output that's positive, right? So it acts just like absolute value. So really what that's saying is the absolute value of x is equal to the square root of a. Whoops, I got that wrong. It should be square root of a, right? And so what's that make x then? Well, x would either equal plus or minus because the absolute value of x is going to make a negative positive. And so if I input a negative, I'm going to get the same thing as if I input a positive, right? So my final answer then is that x equals plus or minus the square root of a. Okay, that's where the plus or minus comes from. Everything in that pink box, you don't have to do that every time. That's just my proof that the plus or minus is there. You just have to remember that when you square root both sides of an equation to include the plus or minus. Okay, why is this such a big deal? Well, when we're solving quadratic equations, not a function, we can treat it the same way we did with a linear equation. When we're solving a quadratic equation where you can point to a single variable, you can isolate that variable by just using inverse operations, which is the easiest way to solve an equation, right? So this is great because sometimes then we can solve more complicated quadratic equations in a very, very simple way by just isolating the variable. That doesn't always work. Like if I had an equation like this, can I point to a single variable there? I can't, right? I see x's there and there. I see x's that show up more than once in the equation, and those are not like terms, so I can't combine them. Everybody see that? So then isolating x is not an option here because there isn't a single x that I can point to, but there is here, right? There's a single x right there that I can point to. So I should be able to isolate it using inverse operations. Okay, I want to point something out here. Notice that what does that P stand for? Parentheses or grouping symbols. That is the last step in inverse operations, right? We don't get to deal with the stuff inside parentheses until the very end. So when we see, what does A and S stand for then? Addition or subtraction. Inside or outside parentheses? No, inside would be P, right? We don't get to the parentheses until the end. This would only be addition or subtraction outside of parentheses, multiplication or division outside of parentheses. You get what see my point? All the stuff that's happening inside the parentheses is off limits until the very last step, okay? That's not an issue here. Here, there's only one thing we have to do to isolate x. Do we have any addition or subtraction to undo? No. Do I have any multiplication or division? No. What's the first thing we have to deal with? An exponent, yeah. Right, here's an exponent. So the first step is just to undo the exponent. How do I undo a squared? Square root. I'm going to use the square root property, exactly. So what do I get then? X equals, okay, which is what? What's my answer going to be? Square root of 49? Not quite, close. Plus or minus the square root of 49, right? Can't forget that plus or minus, right? The fact that we square rooted both sides, means that we have to include that plus or minus in there, right? And what is the square root of 49? 7. Good. So our answers, we get 2 of them. Our answers are plus or minus 7. Okay? Give me thumbs. That make sense? Okay, so this is a great, in certain situations, whenever I can point to a single variable, I can just use inverse operations, which is easy. Thumbs up or down. Can I point to a single variable? Yeah, I can. I see one right there. Okay, so we get to use inverse operations to isolate it then. What's the first step? Got to work up from the bottom.
Addition, subtraction.
Okay, do I need to add or subtract anything?
No.
I don't?
Can you not, because the variable?
My job is to isolate the variable. I'm trying to, every step I take when I'm using inverse operations, every step should reduce something on the side that has the variable and make it closer to being by itself. Isolating means getting it by itself. So what's the first step to getting the x by itself? Add 4. There you go. So first step is addition, and we're going to add 4. Okay, good. What's the next step to get x by itself? Divide by 2. Okay, next step would be division. That's step 2. Okay, last step to get the x by itself. Square root. So what's my answer then? X equals plus or minus the square root of 2. So I get 2 answers, square root of 2 and negative square root of 2. Okay, good? All right. Ooh, how about this one? Yes. Okay, first of all, can I point to a single y in this case? Yes. Okay, first thing, what's the first thing we have to do here? No, because look, my parentheses I don't get to until the very end, right? So exponent, yeah. Notice the only thing that's happening outside of the parentheses is that exponent. So the first step is going to be to undo the exponent. What does that mean? No, I can't. I don't distribute because for 2 reasons. Because can I distribute an exponent when I'm adding or subtracting? No, I can only distribute an exponent when multiplying or dividing. Okay, but I don't want to do that anyway, right? Doing that kind of stuff is counterproductive. I'm trying to isolate a variable. When I'm trying to isolate a variable, that means I want to be erasing stuff from the side with the variable. Every step should accomplish something by getting rid of something and making the variable closer to being by itself, right? So what do I do to erase some stuff, to make the variable closer to being by itself? Square root, right? The way I undo an exponent, the way I undo a squared is to square root both sides. Okay, give me 1 to 5 on that. Everybody see that? Right? We're not trying to like distributing, that's unnecessary. I can point to a single variable. Every step should get closer to isolating that variable. So what does that give me if I square root both sides? What do I get on the left side of the equation after square rooting? Y minus 3, exactly, because look, I'm square rooting cancels the square, doesn't it? Right? So on the left side of the equation, I get y minus 3. What do I get on the right side? 2? Plus or minus 2. 2 is incorrect. Plus or minus 2 is correct, right? Plus or minus the square root of 4, which is plus or minus 2, right? Okay, now, what's the last step? Really, I still technically have those parentheses there. I don't really need to write them. But finally, I get up to the parentheses, and what's the last step inside parentheses to get the y by itself? Add 3. There you go. Okay, and where do I put, notice where we put the 3. We always want, when we add the 3, we always want to put the number that's being added or subtracted in front of the plus or minus. Okay, so I get 3 plus or minus 2. Well, 3 plus 2 is 5. 3 minus 2 is 1. Okay, make sense? Getting the hang of it? Okay. How about one like this?
Do the square root thing.
Okay, first thing would be square root, wouldn't it? Because the first thing I run into is the squared. So first step is square root both sides. What do I get on the left side? 3x minus 17. Right side? Plus or minus square root of 28. Good. Okay, so now what would we probably need to do with that square root? Yeah, good. I got to simplify it, right? So I'll make a factor tree with my 28. Okay, so if I do 28, what would be a good way to break up 28? Yeah, that'd be a good one. Let's put the 4 first and then the 7. What's 4 break up into? Good. I get a couple of 2's and a single 7. So what's the square root of 28 become? 2 square root of 7. Couples go out, singles stay in. So the 2 goes out, 7 stays in. And it just gives me that, right? Okay, now I got inside the parentheses. And so what would be next to get that x by itself? Notice when I get to the parentheses, I want you to see something here. Once I get up to parentheses and I'm looking inside the parentheses, it just recycles the whole stack and I start at the bottom again inside parentheses. So what would I do first? Add 17. Where am I going to put the 17? In front of the plus or minus. Good, it's going to go there. Okay. Last thing, divide by 3. Divide both sides by 3. So my final answer just looks like that. 17 plus or minus 2 times the square root of 7, all divided by 3. I get two answers, one for the plus and one for the minus. This isn't so bad, is it? Right? Not so bad. Okay, one more and I'll turn you guys loose on this stuff. What are you going to do there? Subtract 4. Okay, good. So first step is subtract the 4. Now what? So I get x equals plus or minus the square root of negative 4. Okay, negative inside a square root becomes an I outside, right? It's not a real solution. It's an imaginary solution, but it's still a solution, right? Negative inside becomes an I outside, and the square root of 4 becomes a 2. So I get plus or minus 2I. Make sense? Okay. Go try one on the board. Try that guy. What do you, can you point to a single x? Yes, so we can isolate. What's the first step? Square root. Okay, that's good. What do you get on the left side? What do you get on the right side? Ah, plus or minus the square root of negative 20, right? Okay, we got to simplify that though. Simplify that radical. What does that become?
2 radical 5.
Okay, good. The 20 part, the square root of 20 becomes a 2 radical 5 because I get a couple of 2's and a single 5 when I factor. What happens to the negative? Okay, it becomes an I. There we go. Good. So we end up with plus or minus 2 times the square root of 5 times an I, right? Because that negative inside becomes an I outside. You can put the I in front of the square root if you want to also. Okay, good. So that's what x plus 5 is equal to. So what's the last step? Good. And where do I put the negative 5? In front, right there. So we get x equals -5 plus or minus 2 times the square root of 5i. There's both my answers, one for the plus, one for the minus. When you're entering these, on your homework, and it wants you to separate your solutions with a comma, how would you have to enter those in the answer box?
-5 plus 2 radical 5i, and then same thing with the minus.
Comma, -5 minus. One for the plus, one for the minus. Make sense? Okay. How about it? I'll put the assignment up. People want to test, you can.